I will introduce our keynote speaker today. We are very excited to have Meta come and present. Not only that, we have the head of motion sensors from the Reality Labs at Meta. It is Doruk Senkal. He is the head of motion sensors for the Reality Labs. He does the end-to-end technical roadmap for all the motion sensors at Meta, all their AR, VR, and wearable products. His team has launched amazing world-leading VR products such as Quest and Quest Pro. Prior to Meta, Doruk was at another one of the MSIG member companies, TDK InventSense, where he was leading the next-gen 3-axis gyro design and development. PhD from UC Irvine, 20 conferences, 9 published papers, 16 patents, a real talent in the industry, and we're excited to have him here today. Doruk, the floor is yours. Slide advancers here.
Good morning, everyone, and thank you for having me here. Looks like we have another beautiful day today. So today I'll be talking about MEMS and sensors and how they're enabling us to reimagine how we communicate and compute through the metaverse. We will also talk about some of the challenges we are facing and the opportunities that lie within. A little bit about myself before we begin. My name is Doruk Senkal. I lead the motion sensors group at Meta. We are within an entity called Reality Labs, which is responsible for developing all the hardware platforms, software, and experiences that are eventually going to enable Metaverse. My team is specifically located in the devices org, where we focus on building the hardware. Our mission is to develop, mature, and integrate new MEMS and sensor technologies that are going to go into our products. Well, the title of the talk is Metaverse. So the first question is, what is the Metaverse? I think to truly understand what Metaverse means, we need to look at the evolution of digital communication and computing. If you think about the first days of the internet, it first started with text messages, email, SMS, and so forth. Later, we were able to send pictures in addition to text that allowed us to express ourselves in ways that we were not able to do before. And if you look at what is happening now, the videos are a big part of the communication, right? This is not just for media and entertainment, but we also use it for social purposes or work-related purposes, right? We think that the next step in this evolution is going to be the metaverse. Metaverse will allow users to immerse themselves in a shared and persistent virtual world, where they can interact with a computer-generated environment or other users. In a way, you can think of metaverse as the solution to remove the physical distance among people by enabling users to interact and communicate in ways they have not been able to so far. And let's hear what Mark thinks about the metaverse.
The metaverse, an embodied internet where you're in the experience. Like we're right there with people, no matter how far apart we actually are. That deep feeling of presence. Everything we do online today, connecting socially, entertainment, games, work, is going to be more natural and vivid. Teleporting around the metaverse is going to be like clicking a link on the internet. So even though it's still a long way off, privacy and safety need to be built into the metaverse from day one. But it's going to take all of us, creators, developers, companies of all sizes. Within the next decade, the metaverse will reach 1 billion people, host hundreds of billions of dollars of digital commerce, and support jobs for millions of creators and developers. Beyond the constraints of screens, beyond the limits of distance and physics, beyond any one company. And that will be made by all of us.
I hope you enjoyed the video. Well, there is a saying that Rome was not built in a day. So the metaverse will also need time to build over time. Material Labs is busy building the hardware and platforms that are going to eventually enable the metaverse. These platforms are already enabling users to experience parts of the metaverse and benefit from these experiences. But Metaverse is not owned by Meta or anyone else. Many people are developing different platforms to ultimately enable the metaverse. We at Meta are working on 3 different platforms shown here. The first one is the virtual reality headsets. These are devices where you can interact with the metaverse through a virtual world. And then we have the wearables where you can sense, create, and share content in the metaverse. And AR glasses where you can interact with the metaverse through the physical world. Last year, we shared our vision for the metaverse, a future where you can be present together with people you care and jump into any experience from anywhere in the world. We're at a moment where a lot of the technologies that will power the metaverse are coming together. So our vision is to build all-day wearable, fashionable AR glasses that will transform how we live and work. Mark showed this mock-up of a pair of AR glasses at Connect 2021. I can't really talk about the technology that we may or may not have built in-house yet, but perhaps it is best if we can imagine together what lives would be like with AR glasses.
Good night.
See ya.
Simplify you, classify you, deny, defy, or crucify you. All I really wanna do is, baby, be friends with you. No, and I ain't looking to fight with you, frighten you, or uptighten you. Drag you down, or drain you down, or chain you down, or bring you down. All I really wanna do is, baby, be friends with you. No, and I ain't looking to straight face you, race or chase you, track or trace you, or disgrace you, or displace you, or define you, or confine you. All I really wanna do is, baby, be friends with you. I ain't looking to block you up, shock or knock or dock you up. Analyze you, categorize you, finalize you, advertise you. All I really wanna do is, baby, be friends with you. Oh, and I ain't looking to meet your kin, make you spin or do you in. And I ain't looking for you to feel like me, see like me, or be like me. All I really wanna do is, baby, be friends with you.
So AR headsets will, and the metaverse will allow us to connect with each other, even though we physically cannot be together. In addition, it will allow us to interact with the world in ways we have not been able to so far. And MEMS and sensors are foundational to enable these metaverse experiences. So let's start by talking about what kinds of MEMS and sensors are used in today's platforms. On the left, you can see Quest Pro, our most advanced VR headset to date, which many of you probably have at least somewhat familiarity with. Quest Pro has more than 20 sensors in it. These include MEMS inertial measurement units, also known as IMUs, cameras, magnetometers, Hall effect sensors, proximity sensors, and so much more. Quest Pro is really our first product that delivers many of the features and experiences we just discussed. So let's briefly talk about what features and experiences are enabled by this portfolio of MEMS and sensors. So one of the most essential sensing technologies for AR and VR is head and controller tracking. These provide world-locked rendering, the ability to render 3D scenes that are anchored to the physical world, as well as the capability to interact with this virtual scene. Underlying technology we are using here is what we call visual inertial odometry, as well as simultaneous localization and mapping, SLAM. These technologies allow us to fuse the data coming from inertial measurement units, machine vision cameras, and magnetometers to be able to track the position and orientation of our headsets and controllers. We refer to these technologies collectively as inside-out tracking. The reason for that is that these sensors allow the headset and the controller to perceive the world and localize the systems in the room. This allows the user to put on the headset and start using it immediately without setting up a base station or going through any kind of technical bring up to get their systems going, and lowers the user friction significantly. For head and controller tracking, using high performance sensors is absolutely crucial because any error in sensor output will immediately result in a visual artifact in the form of a swim, drift, or jitter. And this will ultimately degrade the experience that users have in AR and VR. Another important feature for AR and VR is hand and body tracking. These features allow the user to experience co-presence and interact with the environment without the use of controllers. This creates a very immersive experience by bringing your whole body into the metaverse. Underlying technology is computer vision, where we use machine vision cameras and sometimes optical depth sensors to sense the position of the hands and the body. Having the right field of view is crucial for continuous and robust hand and body tracking. So we typically use multiple cameras mounted at different locations on the headset, as well as the controller for this purpose. Pass-through and capture enables mixed reality, the ability to render real world in a VR headset and superimpose virtual objects into this virtual scene. This allows for very novel experiences. For example, you can practice playing a song on a real piano with virtual cues coming from the headset. Another example is being able to play board games with a friend who may not be physically present in the same room with you. Similar to hand and body tracking, we use machine vision cameras and optical depth sensors to enable these experiences. But in addition, we use high resolution color cameras to capture the real world around you in high fidelity. This information is used to recreate the scene through the virtual reality headset. As you might imagine, the real challenges are around using a camera to reproduce what the human eye can see, which means we need real high RGB cameras with low power consumption that can deliver these experiences over a long period of time. Eye and face tracking allows us to render realistic avatars, which is essentially computer generated representation of the user in the metaverse. Without accurate eye and face tracking, these avatars look lifeless and uncanny. Eye tracking by itself, in addition, opens up several other opportunities. You can see, for example, in the image on the left, how the gaze of the user is mapped to a region of interest within the scene. This region of interest within the frame can then be rendered with higher resolution, and the rest of the scene can be rendered with lower resolution, allowing us to save on the computer resources as well as power. Now, there are multiple ways to do this, and industry has been largely focused on camera-based models, but there are other commercially available methods include scanning MEMS technologies, as well as more exotic methods that are being pursued in the R&D. Among the biggest challenges we see in the space include facial hair, such as eyelashes, as well as beard, which occludes the features on the face and the eye. The frame rate is another issue, as we require cameras that have much higher frame rate than a typical camera to be able to capture sudden eye movements as well as fast expressions. Another challenge is finding the right point of view, the right vantage point for these sensors. As you might imagine, these headsets are very close to your face, so being able to see the features necessary to track the face and the eye is challenging. So let's talk a little bit about what are the key challenges that we need to surpass to realize the metaverse vision. The first challenge is in capabilities and performance of the devices. These ultimately determine the feature set and the fidelity of the experiences that we can deliver. For example, we do need displays that have higher fidelity, especially as we start looking into work and productivity use cases, which require a lot of on-screen text at high resolution. Interaction remains to be another challenge, especially in scenarios where the limbs are outside the field of view of the user. And successfully integrating all these subsystems into a highly constrained volume with low power requires subsystems that are highly resilient to external aggressors. We are looking for MEMS and sensors that are really resilient to these unwanted aggressors to be able to basically deliver these capabilities. In addition, we need platforms that are both all-day wearable and socially acceptable to achieve wide-scale adoption. This means we need headsets that are ergonomic and have low weight. So we need smaller MEMS and sensors. We need longer battery life. And since maximum weight of the system is limited, this means we need subsystems that consume lower power. And finally, we need all the tech that is integrated in the headset to be inconspicuous so that the headsets are socially acceptable. Basically, the devices need to look good and they need to feel good. Otherwise, many people will not use these devices, regardless of what kind of capabilities they deliver. And as we look beyond the early adopters and tech enthusiasts, we want the AR/VR systems to be affordable so that everyone can experience the metaverse. Here, the goal is to reduce the total system cost, which can be achieved by either reducing the cost of individual subsystems or reducing the number of total subsystems in the system. Well, at this point, I can hear you saying, well, Doruk, is that all? Will that be everything? Well, yes, these forces are in contradiction to each other, right? Which creates a trilemma of design requirements, where an improvement in performance, for example, may degrade battery life, or adding additional features may add to the total system cost. So there's no free lunch. But I think this is where a lot of the opportunities lie for MEMS and sensors community. What do I mean by that? I believe MEMS is uniquely suited to help breaking out of this design trilemma. Compared to other competing sensing and actuation technologies, MEMS sensors actuators have intrinsically lower size, weight, power, and cost, so obscene. On top of that, they are usually inconspicuous. Because of these reasons, they expect novel MEMS devices to play an important role in enabling a whole range of experiences in all-day wearable and socially acceptable form factors with low cost. When it comes to novel MEMS and sensors, we see development opportunities in three major areas. First of all, to meet the stringent performance requirements, specialty MEMS and CMOS manufacturing technologies, as well as new materials, will be required. Secondly, as the AR/VR platforms shrink further and further, doing more with less is going to be a big theme. So platformization of MEMS and sensors will be extremely important. This will require advances in packaging and interposers, as well as new MEMS and sensors that can serve multiple functions. Finally, intelligent MEMS and sensors will be required to further reduce the power consumption and the compute burden. Here we are looking at on-sensor compute and domain-specific machine learning accelerators to play a key role. Okay, but it is not about only improving the existing features and experiences. We are also looking at innovation to take the form of using existing MEMS and sensors to enable new features and experiences, We can also expect to see never before seen MEMS and sensors to enable these experiences that we may not be even aware of right now. So let's talk about a few new features and experiences we may expect to see in the future. Perhaps one of the biggest opportunities lie in the health and wellness space. We have already seen a strong growth in VR for fitness in the past few years. Essentially, the gamification of exercise is what we are looking at. The ability to create a game around a particular type of exercise routine and being able to provide immediate feedback in the form of a score has the potential to have transformative impact in our lives. What is really missing is that biosensing is largely confined to the wrist right now, and with no coupling to AR and VR. In the future, we see a huge opportunities to feed back biosignals such as heart rate, breathing rate, pulse ox, body temperature, and other high-value biosignals to optimize the fitness, health, or wellness experience that we can deliver to the customer. Another important opportunity lies in haptics. To create fully immersive virtual environments, realistically simulating the sense of touch will be required. What you're seeing in this image is an early prototype of a pair of practical haptic gloves developed using novel sensor and actuator technologies. Unlike today's vibrotactile haptic actuators, these gloves provide force feedback to the user. MEMS technologies has the potential to play a key role in miniaturization of actuators used in this type of gloves. Another interesting opportunity for MEMS actuators lie in displays and optics. To be able to deliver photorealistic visual experiences, we need to look beyond just high resolution and higher brightness and start adding the capability to adapt to the user's eye. Current displays and optics on existing platforms are what I would refer to as passive systems. Displays have a single focal plane, so does the pass-through cameras that we use. This is very different from how the human eye operates, which can focus at different focal planes. This disconnect in capabilities of the display and optics and the human eye creates many unwanted visual artifacts and ultimately responsible for motion sickness. It may one day be resolved by small, lightweight actuators, which may, as you might imagine, take the form of MEMS. As we approach the end of my talk, let's have another look at what the metaverse could look like in the future.
Some people say the metaverse will only be virtual. But one day, this lecture hall will be made of code. And though they're virtual students, what they'll learn together is real. A surgeon will be able to practice as many times as needed in the metaverse before laying her hands on a real patient. Being able to explore a spacecraft is one thing, but the metaverse will let us go farther than any rocket can take us. In the future, students will be able to take a field trip to ancient Rome. And young artists can learn from a masterpiece. Farmers will one day use augmented reality to help ensure the best yields. And urban planners will be able to model traffic solutions to help decrease commute times. So while the metaverse may be virtual, the impact will be real.
I would like to finish my talk with a message. Meta alone cannot build a metaverse. We anticipate partners in different disciplines, such as the MEMS and sensors community, to join us in creating the needed innovations in order to make the metaverse a reality. With that, I hope you enjoyed my talk today, and I want to say I look forward to many opportunities that we'll have to work together and talk about how we can make the metaverse a reality together. Thank you very much.
Did you want to share a DI story?
Yeah, absolutely. So I would like to talk about actually one of the initiatives, DI initiatives we have at Meta. So this is called Meta Elevate. And in the past 3 years, we have reached out to over 2 million members of underrepresented communities for free training in digital skills. And in this year, we are looking to award 100,000 scholarships for professionals in Black communities in areas such as digital marketing and software engineering. So this is a very large scale program which really impact. And I personally think it is awesome because it's free and it is very easy to apply. So I wanted to use this opportunity to kind of share about the program, put the word out there, and hopefully more people can benefit from this program. Thank you.
Okay. Thank you. All right, the floor is open for questions. All right, hands going up. Let's start there.
Great talk. So you mentioned new materials in the MEMS and CMOS. What kind of examples would you be referring to that needs improvement material-wise?
Good question. On the CMOS side, I mean, without going into too much into the technical details, for example, for image sensors, right, to be able to deliver low power, high resolution image sensors, there are different material technologies most likely that will be needed. As you might imagine, a lot of our existing feature sets rely on image sensors. So being able to deliver these features throughout the whole day requires very, very low power circuits. On the MEMS side, you know, again, the silicon is the basic building block there. But for actuation technologies, for example, there's a lot of development that's happening that hopefully will enable new MEMS devices or MEMS devices that are more capable than they are today.
We have a question here from Martin.
Thank you very much. Great talk, Martin Peacock from ZP. You talked about health and wellness, and you showed, you know, the people running through the forest, and you talked about, you know, pulse rate, heart rate. Have you considered the sort of fusion of biological data, lactate in the sweat, cortisol in the sweat, you know, using this as part of sort of gamification? Is there any plans at Meta to bring really the biology and the chemical data into the metaverse?
Yeah, that's an interesting thought. I think there are two aspects to this, right? So the first aspect is health and wellness and fitness, right? The gamification aspect I described. Another opportunity I think lies in telemedicine, where you know, you integrate a number of sensors or essentially a system that you can wear, which allows you to, you know, visit a doctor's office without being present there. And in scenarios like that, yes, absolutely. Being able to measure additional biomarkers can open a lot of new opportunities.
I think we had a question over here.
Yeah, here. Sir Brando from Bosch. So one of the three factors that you described which are basically concurrent to each other, was one of them was the battery lifetime with computing. So in that sense, given that those system will be basically on all day, are you exploring, and what are you exploring in regard to energy harvesting? Is it something you're looking at, or you're relying only in batteries?
Good question. So if you think about power consumption, so the main limitation comes from the fact that we're trying to deliver an experience that is supposed to be on all day, right? From the perspective of energy harvesting, I think there are opportunities there. The biggest challenge lies in the fact that the power consumption for subsystems such as display is fairly high. So I mean, I personally don't expect to be able to keep up with that consumption from just using an energy harvester. There might be opportunities to, you know, feed power to the rest of the system, such as sensors, which are, you know, generally lower power. But I don't think that's going to be the answer by itself.
Yeah, here, Stefan Leidy from Bosch. Yeah, thank you. Great and inspiring talk. You mentioned on-sensor compute and domain-specific accelerators. Do you already have an idea on the architecture on splitting the computation task between the local CPU and the sensors? And second, do you have already a feature set in mind? What kind of functions you would like to have on the sensors?
Can you repeat the last part?
What kind of functions or what feature set do you would like to have on the sensors locally computed?
Okay. Yeah, so again, going back to the discussion around all-day wearability, right? As we start seeing AR glasses, the experience will change throughout the day, right? So for example, you will not have full-on AR, the display system blasting all day, every minute of the day, right? So you can expect, I think, to have different power levels, right, in the system, and go through these, power levels throughout the day. And in these scenarios, I think the on-sensor compute can be really beneficial because that allows us to, put the unwanted parts of the system to sleep, so to speak. Regarding the ML accelerators, I think definitely there are architectures in place. What I would say is that a lot of focus so far has been on computer vision, but I think in the future we can expect to see accelerators for other sensors and other sources of data beyond images.
More question over here.
Yeah, so I'm Naresh from NI. So it's a very nice talk. So you mentioned about there are 20 sensors within the system. So are these sensors all designed at Meta or?
Yeah, without going into too much details, it's a mixture, right? So it depends on what is available at the time and what are our needs. And then we try to find the right balance. Of course, the product schedule and the launch times also is a factor to it. But yes, we do have activities around custom sensors and semi-custom sensors.
Yeah, great. All right. Well, thank you very much. We appreciate it. Let's thank Doruk again.
Thank you.